everyone, and welcome to lesson 22.2. Today's lesson starts on page 308 in your Springboard textbooks, and you will need a pencil and a calculator today. Now, on page 308, we see a couple of triangles here. And what's special about these triangles is they are right triangles, and we have some lengths of particular sides. And they are telling us each time what the hypotenuse is and what our legs are in this triangle. Okay, so labeling these pictures will help us with this last piece, and then the hypotenuse is 15. Okay, now we talked a little bit about SOHCAHTOA before in the prior lesson, and we know that that has to do with the opposite, the adjacent, and the hypotenuse. Now this time we are talking about each time these three angles, so angle A, angle C, and angle E. And we know we have the opposite, the adjacent, and the hypotenuse to those angles in each of the triangles. Opposite, adjacent, hypotenuse, opposite of the angle, adjacent to the angle, hypotenuse length. Right? So we're going to label our picture. What this allows us to do is set up our three trig ratios. So the first one wants O over H, the opposite leg's length over the hypotenuse. So opposite over hypotenuse is 8 over 10, which we know reduces to be 4 over 5. And then opposite over hypotenuse in the second triangle is, this must be a 5. Hypotenuse is 5. 4 over 5. And last but not least, 12 over 15, O over H, which reduces to 4 over 5. So what you may notice here is that all three of these reduce to the same value. Now, when we look at the adjacent side over the hypotenuse, we're going to see a similar trend. We have 6 over 10, which is 3 over 5. We have 3 over 5. And we have 9 over 15, which is also 3 over 5 when we divide both of those by 3. So again, we see this pattern where they simplify to be the same thing. And then finally, when we do opposite over adjacent, 8 over 6 reduces to be 4 over 3. Opposite over adjacent for angle C is 4 over 3. Opposite over adjacent is 12 over 9, which again reduces to be 4 over 3. So we're seeing this consistent pattern. Now, the reason that these are consistent is because angle A, angle C, and angle E all actually measure the same value. All three of these, if we look here, expand out to a 53-degree-ish angle, 52, 53, I believe it's 53 if I line this up correctly. And with that 53-degree angle, again, all of these are that same exact angle measure, right? They're all coming out to be the same value for our angle. And then when we drag it over here, we see, again, same thing, same angle size. So if all of these are 53 degrees, that's going to be important because it's going to see why the relationships between the opposite, and hypotenuse are the same thing each time. The adjacent and the hypotenuse were the same thing each time. And the opposite and the adjacent were the same thing each time. Now, this is also going to relate to our abilities to use our calculator. Now, your calculator we talked about has 3 buttons: sine, cosine, and tangent. And we want to double check that we are, first of all, in the correct mode. So you're going to hit the mode button on your calculator, and you're going to want to double check that you are in degrees mode by scrolling over, hitting enter, and then second quit. Okay, because the mode is going to be important. Now you should stay in this mode unless your calculator needs new batteries, basically. And what we're going to notice is if we hit sine of 53 degrees, that's 0.79, okay, aka right about 0.8. If we do cosine of 53 degrees, that's about 0.6. And if we do tangent of 53 degrees, it's about 1.3. And what we notice is that is the decimal equivalent of each of our values. We had 0.8, 0.6, 1.3. Well, 4/5 is 0.8, 3/5 is 0.6, and 4/3 was the 1.3. So our calculator actually has these trig ratios stored in them for that setup. So we're able to find those values using our calculator since all three of our triangles reduce to be that same measure. Okay. So again, SOHCAHTOA, if we look at page 309, is going to be dependent on whether you're looking at sine, cosine, or tangent, because sine is the opposite side of the angle you're looking at over, not the adjacent, the hypotenuse. That's where the SO comes. So opposite over hypotenuse. Then we have for the cosine, adjacent over hypotenuse, that's the CA. And then finally, we have the opposite over the adjacent, that's the TOA. Okay. And again, we know that this is going to be sine x, if this is our angle, cosine x, so again, x is our angle, and finally, tangent x of our angle. So how does this look when we're setting up these trig ratios? Well, again, it's very dependent upon what angle are you looking at, which of the two acute angles in your right triangle. Because if I'm looking at angle A, my opposite is over here with side BC, my adjacent side is here with AB, and my hypotenuse is AC. I'm going to start by labeling that. Because now if I want the sine, I know I need the opposite over the hypotenuse, which is going to be 8/17, which doesn't reduce at all. The cosine is my adjacent side over my hypotenuse, so that is 15/17. And then last but not least, 8/15, opposite over adjacent, would be our tangent. Now, the reason I say all of this is because now if we look at the second set of examples, angle C is different because angle C is down here, which means the opposite side is now AB, the adjacent side is BC, the hypotenuse is still the same, but our opposite and our adjacent flip-flopped. Okay, so now when I'm looking for the sine of angle C, it's 15/17. The adjacent over the hypotenuse is the 8/17, and opposite over adjacent is going to be 15/8. And you can just leave this as an improper fraction. Even though the numerator is bigger, you'll just leave it like this. Now, what you may notice here is that some of these values are the same. For instance, the sine of angle A equaled the cosine of angle C. Or the sine of angle C equaled the cosine of angle A. So something that we notice, again, what we could say is that our two angles we know will be complementary. And then the sine and the cosine of those complementary angles are going to be equal to each other. So again, angle A is complementary to angle C, since they both have to equal 90 degrees. Add equal 90. And we know from there, for like what we talked about above, that the sine of angle A equals the cosine of angle C, while the sine of angle C equaled the cosine of angle A from up above. So what we can say is that the complements will have the same sign for cosine and sine of those opposite values. So if we know that the sine of 68 degrees is approximately 0.93, we know the cosine of its complement is also going to equal that same value, right? 0.93. So the cosine of 60 minus 90 is 22 degrees. And you can always double check this in your calculator because you could say, okay, the sine of 68 is again about 0.93, and we just said the cosine of its complement, 22, is also that same value. So we double checked using our calculator that worked out. Last two examples are on page 311 in your book. And number 10 relates to that problem we just said. If we have a right triangle named RST and it says the right angle is at angle R. So here is S, here is T if R is our right angle. If we know the cosine of angle S is 0.67, well, we know the cosine of an angle has to be equal to, so cosine of angle S, we know that's going to equal the sine of the complementary angle, which in this case is angle T. So we can say the sine of angle T has to also equal 0.67 because from the previous problem, we know they'll be the same. And finally, in number 11, if we know the sine of angle B, so let's call this angle B, we know the opposite side and the hypotenuse of our triangle. So the opposite side of angle B is 5, the hypotenuse is 13. And using Pythagorean theorem, we have this Pythagorean triple that we can solve for this missing side here. So 169 minus 25 will give us 144. And the square root of that is 12. So what we were able to do is find our missing side here using Pythagorean theorem. And now that we know the opposite side, the hypotenuse, and the adjacent side, we can find the cosine of angle B, which will be adjacent side over hypotenuse. And we can find the tangent, which is the opposite side over the over the adjacent side. Okay. Every time you complete a problem, you want to write SOHCAHTOA on your paper so you can set up those trig ratios. Okay. So drawing a picture and solving for that missing side of 12 will help you then find your remaining two ratios. Thanks for watching, everyone, and we'll work more with this in class.